Hello everyone, this is Sarma Jandarma from Republic of Iraq, Ministry of Electricity, Training and Research Office. I am an electrical engineer. I had master's degree in electrical engineering as Dr. Omar mentioned. I will be with you for around 40 minutes to present this online webinar on efficiency of solar panels and techniques used in manufacturing solar cells. Before we begin, who we are. Training and Research Office. We are one of the formations of the Iraqi Ministry of Electricity. Our responsibilities are training courses for Ministry of Electricity employees and also doing energy research. Training and Energy Office consists of 4 training centers. At north of Iraq, we have Ninawa Center, and at the middle, we have Baghdad and Hilla Center, and at far south, we have Nasriya Center. I'm talking to you now from Ninawa Center. Our mission is to reach the term energy transformation, which is a popular term in the Ministry of Electricity of Iraq after joining our country to Paris Agreement on Climate Change at 2021. Energy transformation means transform from traditional ways like fossil fuels, coal, oil, natural gas of generating electrical power to use renewable energy sources like solar energy, wind, hydro, geothermal energy, etc. This leads me to explain the definition of the terms. The environment. So the environment, according to the Cambridge Dictionary, is the air, water, and land in or on which people, animals, and plants live. And also the terms energy. It's considered a property of matter that it cannot be destroyed, nor can it be created, but rather it's transformed from one form to another and comes in several forms: potential, kinetic, thermal, nuclear, chemical, electrical, electromagnetics, etc. This slide shows how the human's pursuit of energy has negative impact on the environment. As shown, the human's activities like transportation, industries, and power plants will emit from its exhaust the carbon dioxide, which is the dominant gas causing the global warming. As you can see, we have a group of gases causing the global warming called greenhouse gases. The most 2 dominant of these gases are carbon dioxide, CO2, and methane. So, if we want to reduce the effect of global warming, we should make control on the amounts of emissions of carbon dioxide and methane. The power system in general consists of 3 sectors: generation of power and transmission of power, and finally distribution of power. Fortunately, in the transmission and distributions sectors, there is no emissions. The problem with the generation sector. This leads me to explain the term BOE. BOE is barrel of oil equivalent. A barrel of oil equivalent, BOE, is a term used to summarize the amount of energy that is equivalent to the amount of energy found in a barrel of crude oil. It is an American unit of measurement, equals to 159.98 liter, or equivalent to 42 gallons. if I decide to burn 1 BOE, how much energy I will get? 1 BOE equals to 1628.2 kilowatt hour of energy. Now, the amount of CO2 emissions per kilowatt hour. If I use coal, 1 kilowatt hour, I will get, in the other side, I will get 1 kilogram of CO2. So if I burn 1 kilogram of CO2, will give me 1 kilowatt hour. If I use oil, we will have 800 grams of CO2 per kilowatt hour. And if I use natural gas, I will get 500 grams of CO2 emissions per kilowatt hour. And if I decide to change my power plants from traditional power plants to combined cycle natural power plants, I will get 440 grams CO2 per kilowatt hour. Finally, if I use the renewable energies like nuclear power, wind power, hydropower, and solar power are all less than 50 grams of CO2 per kilowatt hour. Now, how to reach the net zero emission? The ways to reach the net zero emissions by applying the following. Number one, make our buildings sustainable by controlling the amount of light and air entered into our buildings and the isolation of walls. This will impact on the amount of energy that we will need it during the different season during the year. We should know the issue, it's like a chain. Low consumptions of energy will give me less operation of power plants to generate the power. As a result, less amounts of emissions. Number two, to reach the net zero emission, using thermal solar and photovoltaic panels. By using thermal solar heaters, we will save a huge amount of energy that we will consume it by electrical heaters for heating the water. As we mentioned above, the issue, it is like a chain. Low consumption of energy, less operation of power plants, as a result, less amount of emissions. Also, using the photovoltaic panels will supply the homes and buildings by electrical power. So this will affect on the amount that we will consume from the national grid. Number three, applying the energy efficiency. The impact and objectives of adopting the principles of energy efficiency and rationalization on the environment will affect on the society and on the government. As a result, saving energy consumptions, the most important of which are: number one, reducing carbon emissions. This is our target. And reducing environmental pollution. Number two, reduce energy costs by improving energy efficiency. Number three, improve air quality. Number four, increase economic benefits by creating job opportunities and supporting the manufacture of highly efficient equipment. Number five, avoid shedding loads at peak times. Also, to reach the net zero emission, I will use the renewable source like green hydrogen and using micro hydro power. Hydrogen is the most abundant chemical structure in the universe, but unfortunately, it not alone, but rather combined with other elements like with oxygen in water, H2O, and with carbon in methane. For that process of getting hydrogen, it's complicated and expensive. Hydrogen classified into several colors depending on the method of separation and the amount of emission during the separation. As you can see, we have gray hydrogen and blue hydrogen and turquoise hydrogen and green hydrogen. The point is, when I trying to get the hydrogen to separate it from another element, I will get some emissions of CO2. So if these emissions escape to atmosphere, I have gray. If I have carbon capture, it will be a blue. And if I use the pyrolysis and I will have a carbon in solid state, I will have turquoise. Which is important for me is the green hydrogen. Production of green hydrogen is CO2 free. There is no CO2 emission. The electricity for the electrolysis of water comes from renewable energies. This means no harmful greenhouse gases are released. For that, it's called green hydrogen. Here, some applications of using hydrogen around the world. We have Alstom company. They announced they are happy to deliver the second train to Puglia state in Italy, additional ones to Lombardy, and also here in India, hydrogen trains after Germany, and here also in Canada. Also, to reach the net zero emissions, we should apply recycling on our wastes. So we have a glass bin and organic bin and paper bin, etc. Also using modern technologies to treat industrial waters and sewage waters. Maybe one of them will ask about what is the relation between the net zero emissions and the treat industrial water and sewage water. Actually, it's contents of methane. So here we need to reduce the methane. Also, we need to add vegetative cover. As you know, the plants take the CO2 from the atmosphere and give us oxygen. Here, this is the a target of municipality of Fatih in Istanbul, Turkey. They announced that the vegetative cover was in 2019 around 875,606 meters square, and at 2023 it became 1,235,555 meters square. It's mean by 4 years they add to the vegetative cover around 400,000 meters square. Also, to reach the net zero emission, and this related to the Ministry of Electricity, we should transition the operation of power stations operating on fossil fuels like oil and coal to using gas, and also using technologies to improve combustions and reduce emissions, such as DLN incinerators. DLN incinerators, it's mean dry, low nitrogen, or by adding chemicals to fossil fuels and using gas disposal techniques. It has symbols SOx for sulfur, NOx for nitrogen, and COX for carbon. After everything that has been shown, based on the emission numbers, it forces us as a Ministry of Electricity to get the energy from renewable sources and change from fossil sources to renewable sources. As known, sources differ from one country to another. For example, in a country like Iceland, there is an abundance of geothermal energy. As for our country, Iraq and Saudi Arabia, Iraq and Saudi Arabia, they enjoy the longest hours of solar radiation, reaching about 6.8 hours per day during the whole days of the year. This leads me to explain the solar system components and factors affect on the efficiency of the system and the methods to enhance the efficiency of the solar system. So any solar system consists of the following. Number one, solar panel. Number two, multi-contacts, MC4 or MC6. Number three, charge controller. Number four, batteries. And until this point, this system is direct current system. So because our appliances is AC, so I need the inverter to convert the power from DC to AC. And finally, I need to protect my system by using protection device. Types of solar panels. We have monofacial solar panel and we have bifacial solar panel. The monofacial solar panel, we have one side of cells and other side is backsheet. And bifacial solar panel, we have a cells on both sides. The cells, it's made from crystal, and we have three types of these crystals. Number one, monocrystal line. Number two, polycrystalline. Number three, amorphous silicon cell, or it's called thin film. And this is the shapes of monocrystalline. It has like octagon shape. And this is the shape of polycrystalline. It's like a square or rectangle. And finally, this is the shape of the thin film or amorphous. Efficiency of solar panels. The engineer and technicians or anyone interested in the subject of solar energy must differentiate between two terms. The first term, nominal power of solar panel. The second term, the efficiency of solar panel. Because unfortunately there is a misunderstanding about the nominal of the panel written on the back of the panel on the nameplate, and about the efficiency of the solar panel. If we have, for example, a solar panel with capacity 415 watts, this means this panel will give me 415 watts if it has standard conditions. So I will get 415 watts if give the solar panel the standard conditions. Okay, what is the condition? What are these conditions? Standard conditions are factory test conditions, which are called standard test condition, for short STC. The first condition, the temperature of the solar cell, which is 25 degrees Celsius, or the equivalent of 77 Fahrenheit. The second condition, a solar panel irradiance of 1000 watts per meter square. The third condition is the air mass 1.5 kilogram. If these three conditions are met, the panel will give me the power written on it, which in our example 415 watts. Now, calculating the efficiency of solar panels. Solar panels are the same as any other system in life. Any system efficiency is an expression of the power coming out, P out, of the system over the power coming in, P in. The power coming out of the panel is the electrical power, P max, while the power coming in, the solar irradiance, multiplied by the area of the solar panel. As shown in the chart, the efficiency of solar panels increased slightly from the year 2013 to the year 2015. If you note, in the 2013, it was 18.2, and in the years 2014, it was 18.5, and in the years 2015, it was 18.7. But between the years 2015 and 2016, there was a leap in efficiency from 18.7 to 21.2. That is in just 1 year. This is because a technology called PERC, P-E-R-C, passivated emitter rare contact, or P-type. This technology has solved many problems in raising the efficiency of solar cells and has prevailed in the solar energy sectors to this day. The figure in front of us is the cells that are composed of. As you can see on the right, the PERC cell is the same of the standard cell, but only we had added 2 layers, the passivated emitter in the front and the passivated rare contact in back. And this is played like a mirror to reflect the escaped electrons that escape from the mutual of P injection happens, and this will reflect as a gain of power. For that we have high efficiency. The second one, an alternative to the PERC technology, is the TOPCon or N-type technology. This is because PERC technology or P-type technology has approached the end of its theoretical efficiency, as it cannot exceed 24.5 in its best cases, and as a result it has stopped. As for the efficiency of TOPCon N-type, according to the research, it reached 28.7, and we as a practical life until now have not reached this number as efficiency yet. Therefore, and because of high theoretical efficiency of this type, N-type, TOPCon, there is a great possibility of paying attention to these cells and increasing their efficiency in the coming years, as they have given successful laboratory results in developing the lifespan of the cells in the field of their system suitability for working at high temperatures like our country, Iraq, due to the improvement of the temperature coefficient for N-type panels due to TOPCon technology. As temperature coefficient has become, as shown in figure, in P-type it was -0.4 and became -0.3 for N-type. The temperature coefficient means how much I will lose from power if the temperature increased 1 degree Celsius over than 25. For this reason, the electrical power production of N-type solar cells increased by about 2% compared to the P-type, and its lifespan also increased from 25 years for P-type to 30 years for N-type. If we look at the figure, which is taken from datasheet of Jinko Solar, which is a Chinese company specialist in production of solar panels, we note that there an increase in production represented by the green color, as well as an increase in the warranty from 25 years to 30 years on a traditional panels. Companies usually give a 25 years guarantee on the production of electrical energy through them, as shown in gray, so that these panels, as shown, produce an equivalent of 84.8 after 25 years of expiry, while N-type panels have a 30 years guarantee on the production of electrical energy, and after 30 years it produced the equivalent of 87.4 of its nominal capacity. In conclusion, it becomes clear to us that there is a significant increase in the production of these cells and in their virtual lifespan, and this is great economic value, especially in large scale projects. And in terms of performance in dim light, which is called low light performance, N-type panels perform better in these conditions and produce electricity earlier than P-type panels in the early morning. They also work for longer time during the day when the sun sets. A daily average of about 2 hours more than P-type, approximately every day. 1 hour early in the morning and 1 hour for sunset, thus increasing the economic schedule for this panel as shown in figure. As for two-sided panels, I mean bifacial, there is an increase in productivity of 2% of N-type bifacial higher than of two-side P-type panels. This increase is the result of increase of bifacial factor of the panels from 70% for P-type to 85% for N-type. Bifacial factor means that the efficiency of the backside compared to the efficiency of the front side of the panel at the same rate of solar radiation. After all that distinguishes of N-type panels over P-type that we mentioned earlier, the chart in front of us below predicts the roadmaps for N-type and P-type's panel for the next 10 years. We note how the market share of the N-type in the year of 2022 did not exceed 20%, and before that in 2021 it occupied only 10% of the market share. The organization VDMA said that the market share of production N-type panels will become about 45 by the year 2026, and it's also expected to capture more than 70% of the market share by the year 2030, compared to less than 30% of P-type panels as shown in figure. Okay, we have the manager, Mr. Maher, Dr. Maher. He want to.
Sorry, Dr. Maher, if you have anything to say, you have any comments?
No, there is no comments. I'll ask in the end. Sorry.
Okay. Yeah. Okay, thank you very much.
So I will go ahead.
Yes, please, yeah.
Regarding solar cell manufacturing techniques, the figure gives us complete picture of cell manufacturing techniques, how they began and where they are headed in the future. About 50 years ago, companies began producing the solar cell P-type, and they are still continuing. These panels are still in possession and controlling of the biggest share of the market share. About 10 years ago, companies began to move into N-type. These panels began to occupy approximately 20% of the market share in the year 2022. There are several technologies for manufacturing N-type panels. The first type technology, or the first generation technology, which is called PERT, PERT. This technology is quite similar to PERC, PERC technology, which is used to manufacture P-type panels. As for second generation technology, it is TOPCon and heterojunction, HIT. TOPCon technology is considered the cheapest and best when compared to the complex and expensive manufacturing process of HIT technology. As shown in figure, there is another technology that comes between the TOPCon and HIT called IBC, integrated back contact, which it can be said that it comes in the middle between the two technologies, TOPCon and heterojunction, and is considered more efficient than both of them. But there are also more complex and more expensive. There are also third generation technologies which are expected during the next 4 to 5 years, and they are mixed between IBC and TOPCon technology, which is called TBC, and also mixed between IBC and HIT, which is called HBC. Here, through the figure below, we will illustrate the difference between the PERC technology, TOPCon, and heterojunction. As you can see, we have layers of each technologies. For the PERC or P-type, we have the coating and N emitter, which is thin, and P silicon substrate, it will be thick. For that, it's called P-type because the P substrate thicker than N emitter, and rare passivation and also coating in the back. The TOPCon technology, we have the N substrate thicker than P emitter, and also we have additional layer which is called tunneling layer. It's behave like a tunnel to move or to drive the electrons to gain more power. And finally, heterojunction technology, it's more complicated than TOPCon and PERC. It has intrinsic silicon layers added to the layers. Here, one by one, we have coating of silicon, N emitter, and silicon substrate, rare contact passivation, and also coating. As we say, because the P layer contains hole and thicker than the N layer, therefore it's called P-type. And the TOPCon technology, also we have the coating, passivation, P emitter, which is thin, and N silicon substrate, which is here thicker than N. For that, it's called N-type. And the tunneling layer is a layer of inert silicon oxide. It is function to prevent the property of recombination. This process, the recombination, will produce heat. Heat, it's the enemy of the efficiency of the solar panels. So if you want to improve the efficiency of the solar panels, you need to decrease the heat. For that, the tunneling layer here prevent the recombination. It's mean decrease the heat generated by the electrons. And also the N-poly layers and silicon coating. Finally, the heterojunction. This technology combines the benefits of the two different types of solar cells into one high-power hybrid solar cell, crystalline silicon and amorphous silicon film. They are made up of thin layers of N-types and P-type silicon and a thin layer of amorphous silicon in between. Acting as intrinsic layer, this is result in higher conversion efficiency and lower recombination rates. As a conclusion, if you are an engineer, technician, or a person interested in the solar energy system, it is best for you in areas characterized by high temperatures, like our country, Iraq, to choose N-type TOPCon panels, as they are cheapest compared to the high-priced heterojunction and they also have low temperature coefficient, which it leads to improved efficiency and is also characterized by the ability to produce electrical power in dim light, I mean early morning or before sunset. And this is what it's make in the forefront at the present time in Iraq. Here I have the actual data or nameplate for the panel. If you can see, we have the rated maximum power 415 watts, power tolerance, it's like from 0 to 5 watt plus minus, current, maximum current 10.15, open circuit voltage it's 14.9, short circuit current 10.66, etc. Here I want to mention about the cell technology. As you can see, the cell technology is mono PERC Si. It's mean silicon mono crystalline with technology PERC. This is my references, and thank you for attention. Dr. Omar.
Thank you very much. Yes, thank you very much, Mr. Sarmat, for the valuable information. Now we open the discussion. So please, if you have any question or comment, you can directly ask Mr. Sarmat. Thank you very much. Is there any question? Yes, Dr. Salwan, you can go ahead.
Assalamu alaikum jami'an. Hello everyone. Mr. Sarmat, I might lost some information that you present. First of all, thank you very much for this presentation. I might lost some of the information due to the technical issue that happened in this meeting, but did you mention anything regarding the cost and for installation? I mean, the cost between the different panels that you presented. Did you have any idea which one is more costly, which one is, I would say, it costs less?
Yeah, I see. Can you hear me, Dr. Salwan?
Sure, yeah, I'm hearing you.
Yeah. I mentioned about the technologies, the heterojunction and TOPCon and PERC. The most expensive one is the heterojunction one. But you know, in the engineering projects, we have two challenges. We have technical challenge and we have financial challenge. If you make a comparison between the heterojunction and TOPCon, the TOPCon will win, because the technical one, the technical specification, heterojunction will win, but in the financial, the TOPCon will win. So if you make the optimization between two of them, TOPCon will win. Did you hear me?
Okay, thanks for the explanation. Yeah, I'm hearing you. Thank you very much for explaining that.
You're welcome.
Thank you. Now we have another question from Dr. Maher. You can go ahead, Doctor. Can you hear us, Dr. Maher?
Hello, can you hear me?
Yes,
Yes,
Doctor. Yes.
Hi everyone. Thank you very much for this informative presentation by Mr. Sarmat. I really enjoy it. However, with some of these technical issues, so we may owe you another presentation, Mr. Sarmat.
You are welcome.
Is that okay with you?
You are welcome.
Thank you very much.
Anytime I'm ready.
Yeah. Thank you very much. I just have a question. Maybe it's not related to the PV solar or solar technology, but because the other question you have been answered already. So my question is about the hydrogen technology.
I see.
So is there any plan, any goal for the Ministry of Electricity in Iraq to implement any such a project on the hydrogen technology or in the storage, hydrogen storage?
To be honest with you, there is some ideas on the papers under study, but on the I mean actual there is nothing, but papers under studying. In the Middle East we have Oman here. They are working on the hydrogen storage projects, and also Egypt, but in Iraq no, everything's on paper until now.
Okay, so in terms of the solar technology and PV solution, if you like, what is the projects, or is there any big projects that already has been developed or have been implemented by the?
We have in Karbala governorate, we have power plants under working. I mean, its capacity around 1.4 giga.
Oh, nice.
Yeah,
Okay.
yeah. I guess in the next 2 years will be I mean on the grid will supply us electricity to the national grid.
Okay, so what is about Mosul?
Mosul, unfortunately, these types of projects, I mean the large projects, PV, it's depends on the I mean another issues like security issues and the stability of the places. And we are in Mosul now, alhamdulillah, it's a great situation. I mean, but they are not stable with Mosul. They are going to the south of Iraq maximum.
Okay. Yeah. My last question is about the PV solar that you just mentioned.
Yeah.
So you already mentioned one of the technology that's well used or adapted in Iraq.
Yeah.
But is that comes from any research?
Yeah,
study and data, or just-
it's come from the actual data on the ground, because our enemy for the solar panel, it's the temperature.
Yeah.
And the TopCon one, it's give us the real data with the temperature. It's more efficient than PERC. For that I mentioned to the TopCon.
Okay. So you have done the characterization of different technologies and
Yes, between
you select-
PERC,
okay.
between PERC and heterojunction and TopCon. But as I mentioned to the Dr. Salwan, because the financial cost, I preferred TopCon than heterojunction.
Okay. Yeah. Thank you very much. Great. Thank you.
You are welcome, Doctor.
Thank you very much, Dr. Maher, and thank you very much for Mr. Engineering for addressing all questions. We can accept more questions if you have. If there is no question, so we can end the webinar, and hopefully we can meet you in the next webinar. We will post any updates about the webinars at the University of Mosul and also on our website. So